Uh, Let us go for this example first. Now, a square mesh concrete column with 600 mm side and 2500 mm high carries an axial load of how many thousand? 600,000 kg. Now remember that the value given here is in kg. So they say the concrete column, you know what is a column, right? Okay. So it is taking up a 600,000 kg load. Okay, load. So let's say, for example, when you refer to this, okay, you can convert it to Newton by multiplying it with 10. So when you multiply it with 10, you have the value here changes to Newton. Okay, we can times it by 10, or you can multiply it by 9.8 or 9.81. Why I use 10 is because it will give me a round figure, okay, without any decimal places. Now, if the concrete density is 2,200 kg per meter cube, now given this is the density of the concrete material, why do they give us this value here? Why do they give us this 2,200 kg over meter cube? Okay, so this one will help us to find out the self weight of the concrete column. Actually, when they give us this value, that means, okay, they want us to include, okay, the self weight of the concrete column. That means the weight of the concrete column itself, okay, is also actually exerting a load, okay, a load, okay, on there is a load acting on the column itself, and based on that, we have to take into consideration of the self weight of the concrete column. Okay, that is only when the density of the material is given. Now, what is the stress at the base of the column? So that is why you have to look at the stress at the base of the column. So when you look at something that is at the base of the column, that means you have to include the self weight of the concrete column. Okay, so I give you the diagram here. So they wanted to know what is the stress acting here at the base of the concrete column at this section here. So first thing is you have to see that is an external applied load actually acting on the concrete column. First thing. Second thing is the weight of this concrete column, because okay, it is actually considered as quite heavy. Okay, so when we say heavy, that means there is a weight, the self weight, W-E-I-G-H-T, of this concrete column alone is acting on, okay, this base here. So if we want to find the actual stress, the total stress acting on the base here, we have to take consideration into this load and the self weight. Now, the applied load is 600,000. So you times with 10 kg over meter square. This is the accelerations due to gravity, the gravitational attraction. So you got this much of load in Newton. You got this much of load in Newton. That is based on this 600,000 kg. Okay. And then based on the self weight of the concrete column, you have to take, okay, the volume, cross-sectional area of the concrete column, multiply by height, give you the volume. So volume is in meter cube. So when you multiply it with density, which is in kg over meter cube, what you get is kg. Then you times it with accelerations due to gravity, that is 10 kg per meter square. What you get is the weight of the concrete column itself. Okay, so area times this height is the volume. So rho here is the density and g here is the gravity. That will give you the self weight of the concrete column. Okay, so that is what you have, 19,800 Newton. So this is based on the self weight, this is based on the applied load. Okay, you can add both of these together to form the total load. To form the total load. Then we know that stress is equals to force over area. The force over cross-sectional area, or the total load divided by the cross-sectional area, that is defined as stress. So we have this. So cross-sectional area, 600 mm sides. They say square, so it is 0.6 times 0.6. So you got this value here, 16.72 meganewton per meter square. That is the stress. Okay, or you can write it as megapascal. Okay, that's for this example.